Okay, so where are we today? So yesterday, this gets us to the end of vectors, all the vector type of problems that come into play. On Friday, we got through components. So I left you with this one to do. We're going to do this first. And then today is just some practice stuff where the solutions are posted. Here in Vanguard, I printed off the practice. So today will be just a work period. So after I do this particular part here, I'm going to stop recording, but I'll stay online if you have any questions, and I'll just work on stuff today. Tomorrow will be probably our first hand-in then, which will be very similar to this. So today is the day to ask questions if you got them. Okay, if you get stuck on something or something like that. All right, starting from where we left off. Okay, we have our vector problem from Friday. So we're going to do components on this one, the last type that we did. So what I'm going to do is just draw these out, which you don't have to, but I'm going to. So there's my north, south, east, west line. Okay, and we've got one vector north 25 degrees to the west. Okay, so that would be going, let's put a vector in there, we'll use a different color. So north 25 degrees to the west. And it's 2340. 2340. This is 25. Okay, so this is going to be AX, and this here is going to be AY. Okay, let me skinny that up so it's easier to write. Okay, so this would be going that way, and this would be going up. Okay, there's our first vector, so let's get each component of it. So AX, okay, we have a 25 degree angle, time, it's that size of vector, meters wise. And because we're looking at the opposite side of the triangle here for the 25 degrees, opposite and hypotenuse is sine. Okay, and then the other one, AY, that would be the 2340 times the cosine. Okay, take your calculator out, go 2340, make sure it's in degrees, sine 25. Okay, so that's 988.9. Okay, we only have 3 significant figures, but I'm going to keep an extra one till the end. Okay, the direction that is pointing is in the negative direction. Okay, it's going backwards. And AY, 2340 times the cosine of 25. That gives us 2121 almost, or 21.20.7. And that's in the positive direction. So there's 2 components. Our second line is slightly shorter and it's going northeast, so it's basically over here. And it's a little shorter, so we'll make it a little shorter. And this is 40 degrees instead. So this is our BX, and our BY is same along the same north line. Okay, so this is 1650. So our BX, or X component of that, would be 1650. Okay, and again, it's with the y-axis here, so this is the opposite side. This is a hypotenuse, that's sine, but it's sine of 40 this time. And BY, okay, BY is adjacent side here, and hypotenuse. So that's cosine. Okay, take our calculator out, plug in those numbers. Okay, 1650 times the sine of 40. Okay, we get 1060.6. Okay, and we know that BX is positive because it's going to the right. And of course, 1650 times the sine. or sorry, the cosine, pardon me, 1650 times the cosine of 40. That's 1264.0. Okay, now that we have both our components, we need to sum the components so that we have the north-south distance and the east-west distance from the start. So we're going to sum our two x's. We have one positive and one negative. So we're going to add negative 900.9 plus 1060.6. Okay, so 1060.6 subtract 988.9, and we get a small value of only 71.7 positive. Okay, so we're going to have pretty much this vector is going to be, as it makes sense, it's going to be very close to that north line. Okay, and our y value. Our y value is going to be large because we have two positive values for y. So we're going to add 2120.7, and we're going to add 1264.0. So 2120.7 plus 1264. Got a huge number there. Okay, so there is we have one large north component and one very small east component. Okay, so we've got a very big, so if we just draw our triangle, a large one like that and a small one like this, and our resultant is here. Okay, so we're going to square these two components to get our value. And we're going to round that off to three significant figures now because there's 3 here and 3 here. So we're going to end up going 3 significant figures once we get the final answer. Don't do rounding off when you're working your problems out. Always do it at the end of your problem, is the general idea. So we're going to take 3,384.7 and square it. And we're going to add the small 71.7 squared. So it's going to be exceptionally close. Okay, and then we're going to square root those. When we do that, our R value becomes 3,385.4 meters, and now we're going to take that to 3 significant figures. So 3,390 meters to 3 significant figures. And we need to know how big this small angle is going to be to get our direction. So we know that it's going to be going north, some little bit west. So we go tangent of theta is 71.7 over that 3,385.4. Notice I'm not using the rounded off stuff until the end. And we're going to take the inverse tan of that. Okay, when we do that huge inverse tan thing, actually it's closer to 70. This is a 5, but it doesn't really matter. I get about 1.2 degrees. Okay, which is only 2 significant figures, but that's good enough in this case, because who's going to measure down past a tenth of a degree, especially with the equipment we have? We don't have really, really good protractors that, you pencil to me. So we'll just go to the nearest tenth. So this is north 1.2 degrees west, or east, sorry. Okay, and that was yesterday. Okay, if you've had 3,390 or 3,385, I wouldn't have freaked out and marked it wrong or anything. I would have just said, watch significant figures. I wouldn't have deducted anything. I usually don't at the beginning. Okay, or if you had 1 degree, that's fine too. So basically north, slightly off of north. we were using the 360-degree method, it'd be like 1 degree off 0 degrees. So that is it for vector algebra. Collinear, perpendicular, cosine and sine law adding, and component adding. Okay, so that's the very first part of physics, doing the math part. Okay, so I'm going to give you a practice. If you go to the Google page, there should be a sheet there. If you're in Vanguard, I printed them off for you. Okay, and we're going to work on this today. I'm going to stop the video, but stay live if you have questions. Solutions, if you go to the video page, so let me bring it over here. Let me just show you where it is here. So if you go on to, let me just log over here. Okay, so if you go in here and you go into Google Classroom, okay, you can check your results. Now physics is here. Okay, and I put up the work is here on day 4. Okay, and I'll put a video underneath it for the solution we did as well. But here's the raw data. Here's the solution data right here. Okay, so you can check this out, check your solutions out. You'll notice that I had to redo this one because I had this backwards when I noticed that yesterday. So there's your solutions. Okay, that's all we're doing today. Okay, I'll stay online in case there's questions, but I'm going to stop the video here. Vanguardians, you can grab a sheet here. I'll put the solutions up on the bulletin board, then you don't have to look online.
That's not for you. Oh, thanks. You take Franz's. Franz can need one.